going to look at topic 5-3 from the Sevis Algebra 2 math book, and we're looking at example 1. We want to graph square root and cube root functions. And so what we're going to do is we're going to look at the graph of the function. We're going to look at the domain and range. So remember, domain refers to the x-axis and the range refers to the y-axis. And the function, if it's increasing or decreasing. So reminder, if the average rate of change across a section of the graph is positive, then you are increasing. And if the average rate of change is negative, you are decreasing. And if your average rate of change is 0, you're neither increasing or decreasing. An average rate of change in a linear function was a slope, but we're looking at curves now, so we're just looking at that positive kind of slope up or down. Best words. So the first part of this example is we're going to be looking at the square root of 3x. Okay, so the most basic thing to do is to always make a t-table. I have a nice little line here in this new software, and I am going to use this nice little line to make sure that my lines are at least straight. It's not going to be the best, but it's going to be a little bit better than what you've seen kind of my sketches in the past. So we're just going to make a t-table. If you remember a t-table back in Algebra 1, you would have your x values here, your f of x values, or your y values on the right-hand side. All right, so looking at this, I'm going to start in a negative. I'm going to start with -1. Well, if I substitute -1 into the square root of 3x, we'll get the square root of -3x, or sorry, -3. And in this case, we're really looking at the imaginary of root 3. And with the imaginary, that's not something we can physically graph. And we don't have that. It's not there. So it's actually kind of undefined graphically. It's not visible in the graph. The next one I'm going to do is 0. Well, the square root of 0 is going to be 0, because 0 times 0 is 0. So 0 squared is 0, and if 0 squared is 0, then that means the square root of 0 is 0. All right, we're going to go with, so I'm dealing with a square root here, so I want to continue with the squares, so I could get whole numbers. So I know that 3 times 3 is 3 squared, and if I took the square root of 3 squared, I would get 3. So 3 times 3 is 9, and the square root of 9 is 3. So here I'm trying to stay with the whole numbers as opposed to going into the decimal realm. It'll be perfectly fine if you go into decimal, but we're doing this without a calculator, so we want to try to kind of avoid that decimal realm. All right. So the next one I'm thinking is, because 3 times 9, that would be 3 cubed, because it's 3 squared times a 3, which would make it a 3 cubed. So the next one I believe is going to be 12, because 12 times 3 is 36. And I know from previous lessons that 36 is equal to 6. And we could continue going through this. They do select number 27 for the next one, so that we can, again, continue that idea of perfect squares. Okay, so now I have my points to graph. We don't have to worry about this one. This graph is not going to graph. Getting that ruler again, because again, my drawings are not the straightest. I mean, even that line wasn't the straightest. I think I'm going to move this down because we're counting upward, and we don't go to the negative y. Give me 1 second. Just gotta move this layer up a little bit. There we go. And flip that around. Again, we don't go beyond 0 on the x-axis, so I am just going to move this over 1 unit and draw my line there. All right, so the first point I'm looking at is 0, 0. The next point is 3, 3. So 1, 2, 3, 1, 2, 3, 1, 2, 3. Then 12, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 6. 1, 2, 3, 4, 5, 6. And then again, 27 and 9. I don't think I'll get that far, but we get a graph that looks something like this. Okay, looking at this graph, our domain starts here when x is equal to 0. So x in our domain has to be greater than or equal to 0. It cannot be less than 0. And another thing to think about here is that our radical has to be greater than or equal to 0. If your radical itself, if the b inside our radical here, if our base inside the radical there is greater than or equal to 0, and I just put b because that could be x plus 5, things like that. But that has to be greater than or equal to 0. So this value right here, anything that's in here, has to be greater than or equal to 0. All right, in our case now, the y does not go below the x-axis. The y actually starts when y is equal to 0, and then it increases. We go positive, so y is always greater than or equal to 0. So there is our domain in range. And then looking at this, we're always increasing. So the graph is always increasing. And again, that's going to look like your average rate of change. So if we look at the slope, my slopes here, even though they're becoming closer and closer to a slope of 0, it's still positive. So our average rate of change is still positive here. All right, so that's part A. As x increases, our graph increases. We have a nice domain, everything in a nice range, and we use the t-table to solve this. So let's look at part B. Part B is g of x is equal to the cubed root, and now we're going away from that square root. We're looking at the cubed root of 2x. Again, I'm going to start with a table of values. I know I have to get the ruler here. Go down like that, spin my ruler around. Up again, drawing my t-table nice and orderly. I'm going to have x here, g of x on the right hand side, and now we're dealing with a cubed root. So if I do something cubed, I can actually go negative. It's not always positive. Like if negative 2 was squared, we would always have a positive 4. But if I did negative 2 cubed, we're doing a negative times a negative times a negative, which means we're looking at a negative 8. So we can look at negative values here. I'm going to try to think of something that will multiply to give cubed. I'm going to go with negative 4. So negative 4 times 2 is going to be negative 8. And if you remember, this is just negative 2 cubed. And my answer here is negative 2. Right, so the next one I'm going to choose is 0. Because again, 0, anything 0 cubed is going to be 0. So that's a pretty quick and easy one. No decimals in there. I'm going to do 4. And we know from before it's negative 2. This is 2. And then what they do is they then go to, and Sevis goes to a decimal. They do 13.5. But you could do any perfect cubed. And so that's going to be 2 times 13.5 is 27. Cubed root of 27 will give us 3. All right, now in this case, I am not going to draw my y and x kind of towards the edge. I'm going to draw them towards the middle because we do have negative y and negative x values in this case. And that's very crooked. I'm going to straighten it out before I draw the line. And that's close enough here. My suffix, and that's actually pretty far off from the middle. Sorry for those who like the lines in the middle, but I'm going to go -4, 1, 1, 2, 3, 4, and go down to 1, 2. What I should really be doing is labeling these -4, then 0 and 0, then 4 and 2, 1, 2, 3, 4. And it looks like there's a rotational symmetry, like if this is an odd function. So this is 4, 5, 6, 7, 8, 9, 10, 11, 12.5, and we're at 3. So since there's a little bit of symmetry, -4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're just barely going to go outside. And with that symmetry, I'm just going to put, and that's not the best graph, but with that symmetry, I'm just going to put that point there. See if I can I draw this a little bit better? Let me see if I could draw this a little bit better. There we go. That's a little bit better. At least it's kind of going through the center. So now looking at this, it doesn't really appear that there is any x values we cannot substitute in without getting any y values in return. So my domain here is all real numbers. And my range here is also all real numbers. I could even do a -infinity, y to infinity. Or I could do the all real numbers, which is that symbol right there. Looking at this, even though it kind of goes from a smaller average rate of change to a greater average rate of change, the average rate of change is positive. So it's increasing over the entire domain. So the graph is increasing over the full domain. And there we go. We got where the domain and range of functions, where it's increasing and decreasing, it's actually not decreasing. And we have graphed square roots and cube roots. So if you have any questions, please post them in the comments of your Google Classroom, and I look forward to seeing you in the next video.